Yeah. Okay, cool. All right. So this is something that we've already covered in a previous chapter, but in this chapter for 5G, it's going to be in a little bit more depth and a little bit more complicated. But I would say, sorry, still at the same level of um, arithmetic. We could say that, right? So in I think it was 5C is when we covered networks. So this topic in 5G, here it is. Okay, is going to be something that we do as well, and something that you've already sort of covered in previous topics with this chapter. So it would be, I think it would be 5C. Yeah, I don't remember the exact chapter, but it's there. All right, so 5B. Sorry, my bad. Okay, so it's something that you've already done, but we're just going to cover it a little bit more in depth. Okay, does anyone remember anything about networks with regards to matrices? So networks or those diagrams that we looked at regarding networks. Anyone remember anything at all? Or features of the diagrams of a network? Anyone remember? I can see Zach moving his hand. Nothing. You guys remember that story or the thing I did with what was it? Chelsea, Kira, Kaya, and Kyla regarding their friendship connections. Okay, where you had like a bunch of dots, okay, and then lines and them getting connected with one another. Okay, this is basically that, but just to the next level. Okay, so if anyone remember what this does anyone remember what this means or what this represents or the name of this? I've already sort of said it, starting with N. It's a network, okay, or a network diagram. Okay, so in this topic, what we're looking at is basically network diagrams, connecting them to matrices, and understanding how connections occur between, could be between people, could be locations, could be something related to IT, because this is, I think, something that they do a lot of when you're programming stuff, how things sort of connect. Where, oh, if this gets turned on, what does that cause for everything else in the program to do? Okay, so networks and connections, okay, are very, very actually applicable in a lot of the things that you do. So most of the times, here's an example, okay, of what a network might look like. So let's say this could be Mr. Todio, okay, and I am connected to mum. That could be dad. That could be sister. That could be dog, and that could be wife. Okay, and then wife is connected to whoever else she's connected to. Okay, and this can be, I don't know, bird. I don't know, whatever. Okay, different connections. Okay, depending on who you're connected to, that person could be connected to someone else. Okay, and they're basically representations of who. In this case, maybe I think a lot of the times it's something to do with communications. Okay, with the questions that we do, I can communicate with mum, sister, dad, dog, wife. Wife can communicate too. This could be, I don't know, grandma, for example, or this could be whoever it is, really. Okay, it represents connections between people. And so, for example, in this one, if I wanted to contact my grandma, I'd have to go through my wife, who will contact my grandma for me. Okay, so that's an example of how you could read that. If my wife wanted to contact the dog, she'd have to go through me, and then I can contact the dog. Okay, silly example, I know, but that's how these connections work with networks. All right. So here is an example. Please copy this in your notes somewhere. So somewhere in the back, and make sure you copy out the arrows as well in this network. Okay, so have this on you in the back of your notes. See, Jordan, I think you're spacing out already, man. And I thought you weren't writing any notes. I'm just waiting to. So write this, copy it down. You've got time now. I'm giving it to you. Copy this diagram. Okay, what does it say now? Exactly. Copy it in your notes, please. Stop arguing and just do it. Okay, if you go through this lesson without doing anything, I'm gonna give you detention. All right, copy this. Make sure you're copying the arrows as well in the direction that they are pointing. So as you're copying, I might just talk through and explain some things. So these links that you see here, okay, are basically, you could say that it's links of how they communicate to one another. So, for example, Vicky can communicate with Stephen, and Stephen can communicate with Vicky. And you can see that because there's one connection there, or it's a direct connection, they only need to communicate to each other in one way or one step. Okay, so it only takes them one step to go from one person to the other between Vicky and Stephen. However, for Vicky to Paul, there is no direct communication. So for Vicky to get to Paul, she needs to take two steps that way, or she could also go two steps this way. So through Kathy and then to Paul, or she could go through Stephen and then Paul. Okay, and it's the same for Paul. If Paul wanted to speak to Vicky, she'd have to go through Stephen and then through to Vicky, or through Kathy and through to Vicky. Okay, so these are what you call, so if they're directly connected, they're called one-step connections, because it only literally takes one step for them to get to that person to connect to them. All right, so for this first question here, we're going to record this into a matrix, okay, into some sort of matrix to represent their connection. So maybe somewhere next to the diagram, let's draw the matrix for it. Now, can anyone tell me how many people are involved in this network? Okay, there's 4. So that means we're also going to have in our matrix a square matrix that has 4 rows and 4 columns. Okay, so these, you can call these nodes, but we'll just call them names or dots for now. Will tell you how many rows and how many columns you have. So whenever you're working with these sort of questions, it's always going to be some sort of square matrix. So let's go and write them down. I'll just use the first letter. So we'll go Vicky, Stephen, Kathy, Paul. It's going to be some sort of square matrix. So give yourself space to do it. So Vicky, Stephen, Kathy, and Paul. And then from there, we write down the connections. Now, one thing that isn't noted here, and I'm not sure if we've come across it yet in any of the questions that we've done, but there are no loops, okay, that occur within this diagram. Does anyone know why there's no loops? Or what is a loop? Ask you that. Yes, Anthony. Back to the same person. So, for example, Vicky communicating with Vicky, there's no loop there. So that means for V to V in my matrix diagram or matrix there, it's going to be 0. Okay, because she can't, or she doesn't technically have a one-step communication to herself. If there was a loop there, then you would write that there is a 1 there, but there isn't. Okay, so she doesn't communicate with herself directly. Okay, so in that case, V to V is 0. Okay, what about Vicky to Stephen? How many connections are there? Just direct connections, one step. 1, yeah, so V to S is 1. V to K, so Vicky to Kathy is also 1, but V to P, 0. Okay, no direct connections. Just for now, okay, when I'm doing this, I'm reading it as from this person to that person. Okay, sometimes when you get into the U12 stuff, it might be reversed. You just got to make sure you read the diagram, okay? Because you might say, oh, it's from here to here. So just be mindful of it. For now, though, I'm just referring to it as from here to there. Okay, so Stephen to Vicky, I can see there's 1. Stephen to Stephen, 0. Stephen to Kathy, there's 1. And then Stephen to Paul, there's 1. K to V is 1. K to S is 1. K to itself is 0. And then K to P is also 1. All right, P to V. Okay, so Paul has no direct connection to Vicky. Again, there's no line there. So that'll be 0. P to S is 1. P to K is 1. And P to itself is 0. So there's my network right there. Okay, also my matrix that represents this diagram. So if I was to ask you guys, and remember, depending on how you read it, in this case, I'm reading it from K, for example, from here. So from, in this case, from this person to this. Okay, so how do we read this network, this diagram, sorry, so this matrix diagram? I might ask Rocco, how do we read this matrix here? If I was to ask you, tell me how I would read this. Good, so I would say this represents the communications of people between the people, and you read it from, for example, from the left, from S, so from Stephen, and you go to the right in the top, and it'll tell you who they're connected to. Okay, so you could say something like that. Normally, I don't think you really get a question like this in year 11, but you might in year 12. Okay, part B. Okay, explain why is there a symmetry about the leading diagonal of the matrix. Now, what that's referring to, okay, so if you look at this leading diagonal with the zeros, look at the numbers on either side of it. Okay, there is some sort of symmetry happening. Okay, what do you guys think that means? When I say symmetry, it's the same. Anthony.
I was just going to say there's no loops almost the same.
Yeah, so, well, yes, that's correct. I'm referring to this, there's no loops. But what this question is asking is on either side, so why are the numbers here the same as the numbers here? They're mirrored, they're symmetric. Why are they the same? Anyone want to take a stab at it? So, for example, if I was to read it, P to S, okay, there's 1, but S to P here is also 1. Or I could go P to S here is also 1. You guys see that? Yes, Rocco. Exactly. Okay, because the communication between those people, looking at the arrows, hence why I told you look at the arrows here, they go both ways. Okay. Now, here's a tricky part, and I don't think it's covered much here. If I was to remove some of these arrows, for example, so let's say I remove Stephen's arrow, Paul's arrow to Stephen, and I'll just make this one connection, a one-step connection from Stephen to Paul. Okay, how does that change our diagram now? So Stephen to Paul, what happens here? There's 1, sorry, I'll leave that here. Sorry, Paul to Stephen, what happens there? It becomes 0 because there's only 1. So now, notice how it's no longer symmetrical. Okay, this number, okay, does not match this number anymore. So it's not symmetrical. Okay, so normally, if the connection goes both ways in your network diagram, then that would mean, okay, then there's going to be some sort of symmetry here with the connections and numbers there. Okay, so that's just something to keep in mind with these sort of questions. All right, question C. What information is given by the sum of a column or a row? Okay, so if I was to add up all the numbers in a row or all the numbers in a column, what would that represent? Yes. Yeah, so the amount of connections that person has maybe going to them, or depending on the question that they have with other people. Okay, so we could leave that there, actually. All right, cool. So now this is the important stuff that we need to get to. So you guys seem to understand how to read these, which is great. Now part D says here n squared gives the number of two-step communications between people, namely the number of ways one person can communicate with another via another person. Okay, find the n squared or the matrix for the matrix n. So what this is saying is this matrix here represents all of the one-step communications. How about the two-step communications? All right, how do we represent that? Now, I feel like, or I would say, this kind of gives it away in terms of how to calculate it, n squared. Okay, you can probably think, oh, okay, you just get that matrix and you square it. Correct, that is true. Okay, but I want to show you how to do it by hand as well, so you understand how this works. So, in the next matrix here, actually, I want, if you can, please label this as one-step communication. Okay, let's do the two-step communications and see how that works. Okay, I'll put that here. Let's use another color. So for two-step, lay out your matrix the same way. It's going to be square matrix. Put in the name, so that's V, S, K, P, and B, S, K, P. All right, so this is where it might get a little bit confusing, okay, with how the two steps work. So when it comes to two steps and the one steps and that sort of thing, you got to be mindful of the arrows, okay, because they tell you what direction they can communicate to, okay? Because these are all double-headed arrows, that means you can go one way but also the other way, okay? So if I was to ask you now, how many two-step communications are there from V to V? So V to itself, if you take 2 steps, okay? So you could count V to S as one step, but then you could also count from S to V as another step. So that becomes essentially a 2-step. So from Vicky to Stephen, there's actually 1 2-step there, and then there's also Vicky to Kathy. So there's 2 2-step communications from V to V. Does everyone see that? So you're basically taking 2 steps or communicating from one person to another. V to S. Okay, how many 2 steps does Vicky have to Stephen? Just 1. Good. And what's that path, Anthony? Well, say that again. Sorry, I can't hear. Wait. So if it's just 2 steps, remember you're going through 2 communications. Good. So you'd go down to Kathy and then up to Stephen. So that's 1 2-step from V to S.
Mr. How's V to V2?
Okay, so from Vicky to Stephen, that's 1 step, and then you can go back because of the double-headed arrow. So that's 2 steps, isn't it?
So there's 2 for itself for everyone.
Well, you would say, depending on this diagonal and the arrowheads, there most likely is 2 for everybody, at least.
What if you square the 1 down?
Say again.
What if you square the 1 squared 1? What if you choose
If you square the 1 squared 1, so these ones you mean? Well, what's 1 squared? Well, yeah, it just stays 1. But let's just go through this for now so that people can understand and see how to at least get the steps. Okay. What are we up to? V to K. So Vicky to Kathy. Okay. So there's that. Well, that won't work. So you'd have to go from Vicky to Stephen to Kathy. That's a 2-step. So V to K is 1, and then V to P. There's 1 there, and Vicky to Kathy is another 1. So 2. Okay. We're up to Stephen now. Stephen to Vicky. Okay, I can see there's 1 there, and that's essentially it. Okay. Stephen to Stephen. So as Fahad mentioned, there's probably going to be at least 2 for most of these. So Stephen to Vicky, back to Stephen is 1. Stephen to Kathy, back to Stephen is 1. And then Stephen to Paul, back to Stephen is also another 1. So there's actually 3 2-steps there for Stephen to Stephen. Okay. And then, what are we? Stephen to Kathy, there's 1. And then there's another 1. And then Stephen to Paul, you've got 1. So this can get a bit tedious, but I'll show you how to do it really quickly on a calculator. Yeah. And the question sort of assumes that, or it kind of alludes to what you need to do there anyway. But let's keep going. K to V. Okay, there's 1 there, I can see. K to V. Oops. K to S. So there's 1, and then 2. Okay, there's 2 there. K to itself. Okay, so this one would be 1, 2, 3. And notice again here, there's going to be also some sort of symmetry as well with some of the numbers. All right, K to P, I can see that there's 1 there. Okay, P to V, so P to V, so 1. Okay, P to S. Oh, sorry. It was, wasn't it? P to V is there. 1, 2. It should be symmetrical. Thank you. P to S, 1. P to K, 1. And then P to itself. Well, there's P to S up there. And then P to K. Okay, so notice again that there is some form of symmetry with some of these. Okay, depending again. But in this case, it won't ask us to interpret that. So for now, here, let's label this as the 2-step communications. Okay, so question E asks us, okay, use the n-squared matrix to find the number of 2-step ways Kathy can communicate to Stephen and write the connection. So what we're looking for is all the connections from Kathy to Stephen. So that would be these numbers. Apparently there are 2. Okay, so looking at the diagram over here, let's write down the connections from Kathy to Stephen. So let's write E here. So Kathy to Stephen, can anyone tell me, there's two there. Anyone tell me one of the connections from Kathy to Stephen? Or what's one of the two-step connections that they have? Yep. Kathy, Paul, Stephen. So you would write K to P to S. Okay, that's one of them. Okay, what about the other one? Where's the other connection? So there's two of them. We've named one. Where's the other? Good. Kathy, Vicky to Stephen. Okay. All right. That's pretty straightforward. And then you could literally answer that way for any other questions that has this. I've seen this in the SAC before, so make sure you write the answer in this manner. Okay. All right. Last one. Question F. In the n squared matrix, there is a 3 where column S meets row S. So column S meets row, sorry, it's not column S meets row S. So right there. What does this represent? So this indicates there's three steps communications that Stephen can have with himself. How would we explain this basically? Okay, so how can we explain this? F. What does that represent? So we're looking at this number here, S to S, Stephen to himself. How is there an explanation that Stephen can have three connections to himself? Okay. Well, one thing you can say is that obviously that he can communicate with himself through Kathy, through Vicky, and through Paul. Okay. Now this is a little bit of a funky question, but maybe think about a real world example where this is a thing. Anyone think of an example where this might be the case? Why would you need to communicate with someone so that they can communicate with you? How about when you tell your mum, Mum, wake me up at 6 in the morning because I've got to go to work. You communicate it to your mum, and then mum will communicate back to you and say, wake up at 6 in the morning. Okay, that's one way. Maybe you could be like, oh, you've sent an email to your workmate and said, hey, can you let me know when this student is coming in? Sure, they're coming in at this time. Okay, that's another example of how this might work. Okay, does that make sense? A bit of a weird question, but you've got to interpret it, I guess, in some different ways. But one thing I've got to show you is how do we get this in a CAS. So get your CASs out because you're not always going to have to expect to do this by hand. Might take some time. So let's get our CASs out really quickly. All right. So on our CAS, I can see that this is going to be a 4x4. So let's make a custom matrix. It's got 4 rows and 4 columns. And let's put our numbers in. So what we're going to do for now is putting the numbers in for the one-step communications. Okay, so you've got 0, and 1, 0, 1, 1, and then 1, 1, 0, and then 0, 1, 0. You don't have to label it, but if you wanted to, you could. For now, I might just leave it. Okay, if you want to know how to label it, remember it's Control, VAR, and then you should have a little arrow, and then call it whatever you want. Now, remember, if you remember the question here for, I think it was D, we're trying to get the two-step. So if we've got this one-step communication, how do we turn it into a two-step? It's pretty easy. You can see there. What do we need to do? Square it. Okay, so you're essentially multiplying it by itself, so squaring it. So that, to square it, you can press x squared. Okay, and then you press enter. There's your two-step. Okay, really easy. And it should be the same as what we got. All right, so you're literally squaring it. How about if I asked you, give me the three-step communication? How would you do that? Okay, how would you do three-step communication, guys? Cube it, so power of 3. Sorry. And 4-step would be the same thing, but I'm not sure if I've ever seen a 4-step question or anything. Maximum is a 3-step. Okay, that's all I've seen. But essentially, all you got to do is just square it, and that'll give you the 2-step. Okay. Cool. That's technically it for this chapter.